Alright, let's go. Number 10. The Grandfather Paradox. In 1943, in occupied France, a novelist named Ren Barjavel was trying to solve a plot problem. He was finishing a book called Le Voyageur Imprudent, The Imprudent Traveler, about a man who builds a machine that moves through time, and he needed an ending. He was not attempting physics, he was attempting a final chapter. The rule he ran into is the most heavily tested assumption in science, and it is so basic that almost nobody states it out loud. Causes come before effects. Every equation, every experiment, every measurement ever recorded assumes the order runs one way. Nothing in the standard framework says what happens if it doesn't. Barjavel's traveler goes back and kills his own ancestor. The novelist noticed what the loop does. It does not contradict itself once and stop. It oscillates. Born, therefore he travels, therefore he kills, therefore he is not born, therefore he does not travel, therefore he is born. The formal physics arrived 48 years later. David Deutsch at the University of Oxford published the first rigorous quantum treatment in Physical Review D, volume 44. In 1991, quantum mechanics near closed time-like lines. His model does not forbid the loop. It computes it. Every proposed escape has been tried. Declare time travel impossible, no law of physics does that, and general relativity actively permits the geometry, which is item 4 on this list. Send the traveler into a branching timeline as Deutsch's model does. The paradox dissolves only because he is no longer visiting his own past. That is not a solution. That is a change of address. Impose consistency by decree, so the gun jams every time, item 7, and the price is higher than most people notice. Invoke Hawking's chronology protection, item 3, never proven. Your entire sense of being a continuous person is a claim about causal order. This memory came before that one. This choice produced that outcome. There is no independent evidence for that ordering. There is only the ordering itself. 83 years on, no physicist has produced a mechanism that forbids this. The paradox was never solved. It was avoided. That was fiction, posing a problem. The next item is a measurement. Number 9. The twin paradox, and why it isn't one. In 1970, Joseph Hafele was a physics lecturer at Washington University in St. Louis, preparing a class on relativity. Running the numbers for a lecture example, he noticed the effect might be large enough for a commercial aircraft to detect. He mentioned it at a conference. Richard Keating, an atomic clock specialist at the U.S. Naval Observatory, was in the audience. Standard reasoning says the scenario is symmetric. One twin flies away at high speed and returns younger, but from the traveler's frame, the stay-at-home twin is the one who moved. Both cannot be younger. That symmetry is why people call it a paradox. The symmetry is false. Only one twin turns around. Acceleration breaks the equivalence, and the two paths through spacetime are different lengths. In October 1971, they bought commercial airline tickets, including seats for 4 cesium beam clocks, and flew around the world twice, eastward and westward. Their results appeared in Science, volume 177, in July 1972. Eastward predicted a loss of 40 nanoseconds plus or minus 23, measured a loss of 59 plus or minus 10. Westward predicted a gain of 275 nanoseconds plus or minus 21, measured a gain of 273 plus or minus 7. The objections came fast, and each one closed. Clock drift, the 4 clocks were cross-compared against the Naval Observatory ensemble. In flight magnetic and thermal effects, modeled, bounded, too small. Statistical fluke, the westward number matched prediction to within 7 nanoseconds. The definitive answer came in September 2010, when Chin-Wen Chao, David Hume, Till Rosenband, and David Wineland at NIST in Boulder published in Science a measurement of gravitational time dilation across a height difference of 33 centimeters. 33 centimeters, roughly the distance from your chest to your eyes. Your head is aging faster than your feet. And it has been since the day you were born. There is no single rate at which you are aging. Different parts of you run at different speeds, and the gap is small only because you happen to be short and slow. That paradox resolved. The next one has no resolution at all. Number 8. The Bootstrap Paradox. In 1941, Robert Heinlein was writing for astounding science fiction under the pen name Anson MacDonald. The story was by his bootstraps, structurally a puzzle box, a man meeting 3 older versions of himself. Heinlein was chasing a narrative trick. He produced a causal structure physics still cannot rule out. The framework here is conservation. Physics keeps a short list of things that cannot be created from nothing. Energy, momentum, angular momentum, electric charge. If something appears without a source, one of those laws is violated, and that is how we catch it. Run the loop and check the list. Nothing is violated. Take 3 versions in ascending order of discomfort. An object, you hand your younger self a pocket watch, and decades later carry that same watch back to hand it over. Information, you take the score of Beethoven's Fifth back to 1804, he publishes it, and the copy you carried was printed from that publication. A person, Heinlein's 1959 story, All You Zombies, in fantasy and science fiction, whose protagonist is both of their own parents. Every time the energy books balance. The momentum books balance. Nobody wrote the symphony. The fixes each fail differently. Branching timelines, following Deutsch's 1991 model, the watch now comes from a parallel history, so it is not the same watch, and the loop never closed. A complexity argument that information cannot appear without an author, there is no such conservation law, and no proposed version survives contact with quantum mechanics. Post-selected consistency, from Seth Lloyd and colleagues at MIT in Physical Review Letters in 2011, it makes the loops probabilistically well-behaved. It does not give the score an author. Consider what you know that you were not told. Your name, your language, your model of the world all arrived from somewhere upstream. You have never verified the origin of any of it. Only the chain. Energy is conserved, momentum is conserved, origin is not on the list, and nobody has explained why it should be. There is a way to close every one of these loops cleanly. It arrived in the 1970s. Number 7. Novikov self-consistency. Igor Novikov was a Soviet astrophysicist working on the interiors of collapsed objects in the 1970s, and he was not trying to rescue time travel. He wanted to know whether general relativity produces well-posed problems in spacetimes containing loops. A question about mathematics, not about grandfathers. The demand is simple. A physical theory must give exactly one consistent history from a given set of initial conditions. If a loop can produce a contradiction, the theory has failed as a theory. Novikov's finding was that it excludes itself. The equations only admit solutions in which nothing contradicts, not because something intervenes. Because contradictory solutions are not solutions. The hard work came in 1990 and 1991. John Friedman, Michael Morris, Novikov, Kip Thorne, and colleagues published Cauchy problem in spacetimes with closed time-like curves in Physical Review D, Volume 42. Then Fernando Echevarria, Gunnar Klinkhammer, and Thorne at Caltech ran the concrete version in Physical Review D, Volume 44. In 1991, billiard balls fired through a wormhole on trajectories designed to knock their earlier selves off course. Self-consistent solutions existed for every initial condition, usually infinitely many of them. Every objection has been answered, and that is the problem. Say the probability of a paradox is merely very low. Novikov's result is exactly 0. Say the ball could be nudged off course, the calculation returns another self-consistent trajectory. Say the traveler could simply choose to shoot. The equations contain no term for choosing. The universe never runs out of ways to keep the story straight. Now apply the same logic to yourself, because there is no version of it that applies only to time travelers. If the future already exists in a form that the past must be consistent with, then the reason you cannot change what happened is the same reason you cannot change what will. Novikov was offered as the solution to the grandfather paradox. Which of the two is worse depends entirely on how much you wanted your decisions to be yours. All of this was argument. In 2009, someone finally ran the experiment. Number 6. Hawking's Party for Time Travelers. Stephen Hawking spent his career on singularities, black hole radiation, and the structure of space-time. In 2009, while working on a television project, he set up something never done in a laboratory or anywhere else, a controlled test for the existence of time travelers. The reasoning is thin but not stupid. If backward travel is ever achieved at any point in the future of the species, the set of destinations includes any moment precisely specified and publicly recorded. One documented arrival ends the debate permanently. On 28 June 2009 at Gonville and Caius College in Cambridge, there was champagne, there were balloons, and there was a banner reading "Welcome, Time Travelers." Hawking sat in the room alone. He sent the invitations out the following day. Nobody came. The second data point is systematic. In 2013, Robert Nemiroff and Teresa Wilson at Michigan Technological University published a search for prescient content online. Mentions of Comet Ison and of Pope Francis appearing anywhere before those names existed. They searched Twitter, Google+, Facebook, and Bing, and invited any time traveler to send a message to a specific address before a specific date. Nothing, in either channel. The honest reading of a null result is that it is weak. Perhaps travelers cannot reach a moment before their machine was built. That constraint appears in most wormhole models. Perhaps they arrived and stayed quiet. Perhaps the species never survives to build one. Two independent searches for evidence that anyone from your future is walking around your present. Two empty sets. It is thin evidence, and it is the only evidence anybody has. Absence of visitors is one thing. The next item shows the door was never locked. Number 5. The Tachyonic Antitelephone. In 1917, Richard Tolman was writing a textbook. The theory of the relativity of motion was meant as a careful exposition of Einstein's new work, and while tidying up the consequences of the Lorentz transformation. Tolman worked out what happens to a signal that outruns light. He was doing bookkeeping. He found a hole in causality. The standard reading is that faster-than-light travel is forbidden because objects cannot be pushed past light speed, infinite energy, infinite mass, the familiar wall. That is the version everyone is taught. That version is wrong about the reason. Relativity does not forbid faster-than-light signaling because it is hard. It forbids it because faster-than-light signaling and backward time travel are the same operation, seen from two frames. Stage it. Gregory Benford, David Book, and William Newcomb named the device in Physical Review D, Volume 2 in 1970. Alice and Bob are on ships separating at 0. 8 light speed, each carrying a transmitter that sends at twice light speed. Alice transmits at 12:00 by her clock. Bob receives it and replies at once. In Alice's frame, his reply arrives at 11:58, 2 minutes before she sent hers. Every escape has been examined, and none holds. Gerald Feinberg's 1967 reinterpretation principle in Physical Review. Recasting backward-traveling tachyons as ordinary particles moving forward, it works for single particles and fails for modulated signals, which is to say, for messages. Tachyonic fields in quantum field theory, these describe unstable vacua, not superluminal particles. Direct searches in cosmic rays and accelerators, nothing, across 6 decades. Miguel Alcubierre's 1994 paper in Classical and Quantum Gravity avoids local light speed violation entirely by moving space itself. Then Alan Everett showed in Physical Review D in 1996 that 2 Alcubierre bubbles can be arranged into a closed time-like curve. Every faster-than-light concept you have ever encountered in fiction carries this attached. Not as a side effect. As the same fact restated, warp drives, wormholes, every FDL proposal ever drawn. They are not transport technologies. They are causality violations with better marketing. Fiction aside, general relativity has permitted this since 1949, in writing. Number 4. Gödel's rotating universe. Kurt Gödel was a logician, not a cosmologist. He had proved in 1931 that formal systems contain true statements they cannot prove, and at Princeton in the late 1940s he spent his walks with his closest friend Albert Einstein arguing about time. For Einstein's 70th birthday in 1949, Gödel handed him a present, an exact solution to the field equations of general relativity. General relativity relates matter to the shape of spacetime. It does not come with a list of permitted universes. Whatever satisfies the equations is a legitimate solution. Gödel's solution describes a universe filled with rotating dust. In it, closed time-like curves exist, paths through spacetime that return to their own starting point. Travel far enough in one direction and you arrive in your own past. No wormhole. No machine. You just go. The solution appeared in Reviews of Modern Physics, Volume 21, in 1949, an example of a new type of cosmological solution of Einstein's field equations of gravitation. It requires a negative cosmological constant and a global rotation, and the loops only open beyond a critical radius, requiring travel above roughly 71% of light speed. Einstein's published reply, in the same birthday volume, conceded that the solution was valid, said the problem had troubled him since he built the theory, and suggested such possibilities might be excluded on physical grounds. He did not say which grounds. Every exclusion offered since is observational, not theoretical. Our universe is expanding. Gödel's is not. Our cosmological constant is positive. Global rotation is constrained by the isotropy of the microwave background. Alan Kogut, Gary Hinshaw, and Anthony Banday used COBE data in Physical Review D in 1997 to push any large-scale rotation far below what GL's geometry requires. Each says the same thing. Our universe does not appear to be that one. None says the equations forbid it. 77 years later, nobody has produced the rule Einstein wanted. Time travel is not forbidden by general relativity. It is merely absent from the particular solution we happen to inhabit. Something does seem to stop it. In 1992, Hawking gave that something a name. Number 3. The Chronology protection conjecture. By the late 1980s, Kip Thorne's group at Caltech had shown that a traversable wormhole with one mouth moved at relativistic speed becomes a time machine. Hawking's response was not philosophical. He went looking for a physical mechanism that would break the machine before it worked, and he looked in quantum field theory. The relevant object is the Cauchy horizon, the surface in spacetime beyond which initial conditions stop determining the future, the exact boundary at which the loop closes. Classically, it is an ordinary surface. Nothing special happens there. Quantum mechanically, it is not ordinary. Vacuum fluctuations circulate the closing loop repeatedly, and the stress energy piles up with each circuit. As the horizon forms, the calculated energy density diverges. Hawking published Chronology protection conjecture in Physical Review D, Volume 46, in 1992. The mechanism destroys the loop at the moment of formation, and his conclusion was that the laws of physics conspire to keep the universe safe for historians. Then, the counterexamples arrived. Sung-Won Kim and Thorne had already argued in 1991 that quantum gravity should cut the divergence off at the Planck scale, around 10 to the minus 35 meters, leaving the loop intact. Matt Visser and Sergei Krasnikov built geometries in the mid-1990s where the divergence never appears. Li-Shin Lee and J. Richard Gott published a self-consistent vacuum state in Physical Review Letters in 1998 with finite stress energy at the horizon. And the core problem never moved. Settling this requires a working theory of quantum gravity, and after a century of effort there isn't one. Note what you rely on when you assume your past is fixed. Not a law. A conjecture named in 1992, still unproven, defended by an argument its own author called a conjecture. Physics did not discover a law preventing time travel. Physics observed that time travel does not seem to happen, and gave that observation a name. That was theory about the past. The next item is an experiment that has been run. Number 2. The delayed choice quantum eraser. John Wheeler spent the 1970s sharpening what the double-slit experiment actually says. His question was narrow and mechanical. At what moment does a photon commit to behaving as a wave or a particle? In 1978, he proposed delaying the choice of measurement until after the photon has passed the slits, after, as he put it, it has already decided. The textbook account says the apparatus determines the outcome. Detect the path, you get particles and no interference. Erase the path information, you get interference. The buried assumption is that this is settled before detection. Yoon-Ho Kim, Rong Yu, Sergei Kulik, Yanhua Shi, and Marlon Scully built the version that removes that assumption. The choice is made after the photon has been detected. Their paper appeared as a preprint in 1999 and in Physical Review Letters, Volume 84 in 2000. A beta barium borate crystal splits each photon into an entangled pair. The signal photon takes a short path to detector D0 and is recorded. The idler takes a longer path to one of 4 detectors. D3 and D4 preserve path information. D1 and D2 destroy it. The idler arrives roughly 8 nanoseconds after its partner has already been measured. Sorted by idler detector, D1 and D2 coincidences show interference fringes. D3 and D4 show none. The popular reading is that the future changed the past. Let it sit, because it is nearly convincing, then take it apart. The raw D0 data contains no interference at any point. It never did. The fringes appear only once you sort detections by where the idler landed, and the 2 subsets are offset so that they sum exactly to the flat curve you already had. Nothing in the earlier data changed. You were looking at a mixture, and the later measurement told you how to separate it. No signal travels backwards, and Vincent Jacques and colleagues confirmed it with a single photon Mach-Zehnder interferometer in Science in 2007. Correcting the myth does not dissolve the problem, and this is the part that gets lost. Something still determines which subset a given photon belongs to. Whatever that is, it was not fixed at the moment that photon was recorded. The past is not being rewritten, it is being resolved. The distinction between changed and undetermined is the whole argument, and almost nobody makes it. Which leaves the last item, and it is not about photons. It is about whoever is watching. Number 1. The Boltzmann Brain Paradox. In 1895, Ludwig Boltzmann was defending the second law of thermodynamics against a hard objection. If entropy always increases, why is the universe so ordered? In a letter to Nature, he floated an answer, crediting it to his assistant, Dr. Schetz. Perhaps the universe as a whole sits in thermal equilibrium, and the ordered region we occupy is a statistical fluctuation. A rare dip in an eternity of chaos. The mathematics is straightforward. Given infinite time, any physically permitted configuration of matter eventually assembles by chance. Every configuration, including a brain, a conscious observer, complete with memories of a childhood, a career, a Tuesday afternoon. The cost of a fluctuation scales with its size. A single brain with false memories is overwhelmingly cheaper than an entire 13.8 billion year universe that produced a real one. The modern version arrived with a positive cosmological constant. Lisa Dyson, Matthew Kleben, and Leonard Susskind published disturbing implications of a cosmological constant in the Journal of High Energy Physics in 2002. Andreas Albrecht and Lorenzo Sorbo at UC Davis followed with Can the Universe Afford Inflation? In Physical Review D, Volume 70 in 2004. In an eternally expanding de Sitter space, the wait for a fluctuation brain runs to something on the order of 10 to the power of 10 to the power of 50 years, and the universe has that long and longer. Ordinary observers are made once, in a narrow early window. Fluctuation observers are made forever. Count them and ordinary observers lose by a margin with no useful name. Then the argument turns on itself, and this is the move that matters. A fluctuation brain's memories are random. Its laboratory notebooks, its telescope data, its recollection of ever having read a physics paper. All of it assembled by chance, none of it evidence of anything. Which means a cosmological model predicting that most observers are fluctuations has undermined the observations used to build it. Sean Carroll's term for this is cognitive instability. The theory, if believed, destroys its own support. This is why no working cosmologist treats it as a description of reality. It functions as a reductio, a diagnostic that a model has gone wrong. Don Page has used it to argue our vacuum must decay on a finite timescale. Kimberly Body? Carroll and Jason Pollock argued in 2017 that a quantum vacuum state does not dynamically fluctuate at all, removing the brains entirely. Models predicting a preponderance of Boltzmann brains are discarded for predicting them. Do not leave here in nihilism, because that is not what the argument says. The strange position it leaves you in is this: the strongest argument that you are real is not evidence. It is that the alternative makes every argument, including this one, meaningless. You are not proven real. You are assumed real, because nothing works otherwise. Every item on this list sits in the same place, and it is not where people expect. Not at the frontier, not in the exotic margins where data runs thin. Barjavel's loop lives inside causality. Hafeel and Keating's clocks live inside special relativity. Gödel's universe is an exact solution to the most confirmed theory we have. The Boltzmann problem follows from thermodynamics and a cosmological constant we measured. None of these are gaps in our knowledge. They are load-bearing walls, and they do not meet at the corners. The universe is not confused about what it is doing. We are the ones holding the blueprint upside down, insisting the building must be wrong. If you want to see more videos like this, click the video on screen now.